The next one, less calculus, more trig. If you want to find a tangent at the pole, we know it exists if the function of theta, which is r, is equal to 0 and the derivative does not equal to 0. Basically, we just have theta equals to an angle. So how can we find all the tangents at the pole? R equals 2 cosine 3 theta. Again, I would encourage you to graph that. So I've gone to Desmos, I've graphed it, and I can see that we have 3 loops. And if you wanted to plot just a few points so you could kind of see where it was going, when theta is 0, cosine is 1, so we would have 2, that's this point. And then if you let theta equal to 30 degrees or pi over 6, why I chose 30 is because when I multiply it times 3 I get 90 degrees, and the cosine of 90 is 0, right? Meaning it goes to from here to here. And again, if you weren't sure about that, you could plot some other points smaller than 30 degrees and kind of see what happens. But it goes through the pole when theta is pi over 6. And then it goes to the pole again and again. How do we find all those values? Let's do some trig. We set them equal to 0. We set the function, which is r, equal to 0. We divide by 2. And then we take the inverse cosine of both sides. And you've got to look at that. That tells you that your interval for solving is bigger than 0 to 2 pi. You've got to go around the circle like 3 times. So when does cosine equal to 0? Well, that's twice from 0 to 2 pi. Keeps going, keeps going. So 3 theta equals to pi over 2, 3 pi over 2. That's this one and this one, but we got to keep going. Just add 2 pi. So we're going to have 5 pi over 2 and 7 pi over 2. I got to go one more time, so add 2 pi. 9 pi over 2 and 11 pi over 2. Now that's equal to 3 theta, but I got to solve for theta. So I have these 6 values. Now divide all of those by 3. And I know this is really sloppy. Bear with me. So theta is going to be pi over 6. And if I divide this one by 3, I would get just pi over 2. Then 5 pi over 6, 7 pi over 6. If I divide that one by 3, where are all those lines? Well, this line is at pi over 6, but it's also known as 7 pi over 6. So really, these two are the same line. Okay. Then, when else does it go through the pole? Well, it looks like we have pi over 2 and 3 pi over 2, which is right there. And then 5 pi over 6 is when it comes, it's coming around, and it goes to the pole right there. So we have 5 pi over 6 on this end and 11 pi over 6 on this end. Do you have to write all 6? No. You have to have at least the 3. Let's see, whatever 3 I mentioned. So pi over 6, so pi over 6, pi over 2, 5 pi over 6, that would get it. Okay. You just have to know that you didn't have just 1 or 2 answers. Well, where was the other part of this? It also said the derivative cannot equal to 0 at those values. I guess we should check that. So let's take the derivative of r. So if we have r equals 2 cosine 3 theta, and we take the derivative, remember that's our function of theta, we take the derivative here, the derivative of cosine is negative sine, so we would have negative 2 because of the 2, then sine of 3 theta, but then we would have to also multiply by that 3. So we'd have negative 6 sine of 3 theta. Is that going to equal to 0 any of these values? Well, let's see. If I divide by negative 6, I get 0. So I get the same equation except in terms of sine. And sine and cosine are not going to equal to 0 at the same time, so these are okay. So to find tangents at the pole, set that function equal to 0. Be careful of your angle. If it's bigger than just 1 theta, get those multiple answers.